Hello class, we're going to be looking at Unit 6 today. Unit 6 covers functions, and we're going to be splitting this unit up into little pieces, so maybe 3 different videos to cover it. Anyways, we're going to start with this idea of functions. Notice that this code here is quite repetitive. And we learned previously that one way to remove repetitive code is by using a loop. So instead of copying the same line over and over and over again, we can create a loop which executes that single line or multiple lines many times. Now, if we look at this code here, we see a decent amount of repetition, although it's not quite apparent how we would really remove it with a loop. In fact, it doesn't really seem possible because, like this statement here in yellow, it does repeat 3 times, but then there's 3 different things, very different things in between. And so a loop really wouldn't work for this. And then we also see some more repetition with this formula here, 4/3 pi r cubed, but the variable is, or the radius is different, and sometimes I'm printing out different statements, and so it's not something that is something that we could turn into a loop very easily. But there is a way in Python and really all programming languages to condense this code that is used often repeatedly. We could actually create into what we call functions. Now, functions, like I said, are used to simplify repeated sequences of code, and it's used to organize your program into chunks of functionality. It's kind of like when you write paragraphs. This paragraph talks about this, and this paragraph talks about this. Functions can hide details, and so, if we have the turtle function and we want to move forward, instead of having 10 lines of code to make the turtle move forward and repeatedly copy those codes, we just say turtle.forward, and we understand what this method does. It hides the details of how it moves the turtle forward, and it makes it very readable. We see the code there, and we say, oh, okay, the turtle is moving forward by some distance. Okay, first off, I'm going to diagram just a generic function that takes an input, and notice here does not provide any output. We're going to see functions later on that also give an output, but we're going to start with just a function that is receiving an input. And we've seen a function like that, the turtle function, that moves forward. It receives an input, a distance amount to move forward. And we put it right in the brackets, right inside there. And it might seem that it has an output, but it actually doesn't. It does make the turtle move forward, so there is some activity that is done inside this function, but technically this function does not have an output. So, in math we have f of x, and we might define a function f of x equals x plus 5. This is a linear function. Whatever the input is, we add 5 to it. This is what we would call the mathematical grammar to define a function. So we need a similar grammar to define functions in Python. So this is the grammar for defining a function. It's a compound statement, meaning it takes up multiple lines of Python code. The very first line starts with this keyword def, D-E-F, define. And then the next word is any sort of legal function name that you like, something that is descriptive, something that might be verb-like, like move forward, something like that. Then we have parentheses here, and inside the parentheses, separated by commas, is all the different inputs we might want this function to receive. Now, it is optional. We don't have to have any inputs for our function. So if that were the case, we would just put parentheses, closed end parentheses with nothing inside of it. And then the last thing we have to remember is the colon at the very end. So this is the very first line that defines the function name, and it defines the number of inputs that are given to that function. And these variable names here can be whatever you like to use, whatever are, again, good descriptive variable names that give an idea of the meaning. Then we have the code inside the function, and just like the for statement that we learned previously, we always indent these statements by the same amount. And we could have any number of statements inside of this function, and once we stop indenting, once we have a statement that is unindented, such as this statement right here, we know that that is outside the function. And so just these statements here would be part of the function that we're defining. Okay, so let's see how we would use this in kind of a real specific case. So I want to create a function. I use the word def. Introduce me is the name of the function I want to make. I have two inputs. One input is called name, and the other is called fav food. And the intention is for both of these to be strings, because I want to print out a message using these two variables. So the first statement inside the function will be printing out my name is whatever the string is. And then again, I like this favorite food. Note that this is only the definition of the function and nothing actually happens yet. If I were to type this into Python and if I hit the run button, nothing would happen. It's similar to this idea here. So suppose I have the function f of x is equal to x plus 5. This is the mathematical definition of the function. But at this point, I'm not really using the function yet. So if I said, oh, okay, well, f of 5, in that case, I'm using the function. I'm using the function with an input of 5. I'm calling the function. So in a similar way, in Python, we actually have to call the function in order to use it. And so this is what we do. We use the word calling. We also use the word invoking a function. So basically, syntax is very straightforward. We just give the function name followed by the parentheses, followed by whatever inputs are required by that function. In this case, we require two strings, and so we need to supply that. The order matters. If I wanted to, I could supply a variable that was a string, or I could even supply an expression that creates the string as well. So in this case, what happens? How does this work? When I execute the very first line, this introduce me Mark Hamburger, what will happen is that these two inputs will be, you could say, copied into this parameter up here. So name will receive the object mark, and fav food will be referencing this hamburger object. Okay, so it's kind of like plugging in the value. When you have f of 5, you plug 5 into the x. And similarly, we plug mark into name, and we plug hamburger into fav food. That's the way you can kind of think about it. Then we execute the lines inside the function. My name is, and we print out whatever the name is, which happened to be Mark, and so we see the first line here. We execute the second statement, I like this variable fav food, which happened to have the value hamburger in it, so I like hamburger. So that would be what generates the first two lines of the printout here. Okay, then we execute Then we're done with the function. When we're done with the function, we then exit out and resume from where we had left off. And so the next line here is another function call, this time with John and pizza. So again, what happens is that these two strings will get plugged into these two variables again. And so now name references John, fave food will reference pizza, so that when we execute these two lines again, it will print out my name is John, I like pizza. Okay. Okay, so previously we just looked at a function here that really did not produce any output. And it's, in some ways you might think, oh, but it did print out some messages, and that's true, but technically speaking, we're going to say that the function did not output anything. And so I want to talk about fruitful functions now, and fruitful functions are functions that output some value, and the term that we'll hear a lot is that it's a function that returns some value. So in this case, we have a picture of a function that is returning, outputting some number that happens to be the average of all the inputs that were supplied to it. Note, this is very important. Returning a value is not the same as printing a value out. So, in the previous example here, we're printing here. We're printing out information out to the console, but that is not what we mean when we say we're outputting a value from the function. It does not mean we're returning anything from the function. Okay. So let's look at a return and kind of try to understand what it does better. So the syntax is you basically say return some value. And this value can be a variable. It could be a number that you put in there. I could return the value 1 or return the value 0. I could put x plus 5 inside there. Whatever I want, I could return that value. Now, typically the return statement will be the last statement of your function, but it doesn't have to be the last statement. But you do need to understand that whenever the Python sees the return statement in a function, it will immediately end execution of that function. So suppose I had just written up a function that had some statements underneath it. And so I'm executing this function, I'm executing these statements here, then I hit the return statement. And at that point, the function ends. It stops, it returns this value back to the caller, and these statements literally do not get executed at all. So it does not make any sense, actually, to type anything after the return statement here. Now, we will see later on situations where we have return statements in the code in other places, but there's special reasons why we do it, which we'll get to later on. But right now, it's really important to understand that once we hit a return instruction, we exit out completely from the function. Now, what do we do with the return value? Typically, the return value is assigned to a variable, or possibly it's used as an input to another function. So let's look at some examples of that. So I'm defining here a function called sphere volume, which takes in an input r, which is the radius. And I'm going to return the volume of the sphere using the volume equation 4/3 pi r cubed. Notice, again, I am not printing it out. I'm returning it. I am outputting it back to the original caller of the function. Okay, so now, let me label these lines. So line 1, line 2, line 3, 4, and 5. When Python starts executing the code, it starts at line 1, and it says, okay, what do I do? It sees the define statement, and it really doesn't execute anything at this point, but what it does is it just kind of registers the fact that there was this function called sphere volume at line 1 so that it knows that it exists and that it can be called later on. So then we skip all the way to line 3 and we execute this first line. This variable num is created and it's going to get assigned to the answer, the output, the return value of this function. So we call this function, and when we call this function, the 4 here will be plugged into R. We calculate the volume of it. It'll be some value, and that value then is going to be returned back to the caller, and in this case it said num is equal to it, so in this case the number will receive the volume of the sphere of radius 4. Okay, so this is an example where we have an equal sign to receive the answer. Okay, another way we can deal with it is, let's look at the second example. Line 4 then gets executed, and in this case, we calculate the volume of sphere with radius 5. 5 will get plugged in here. The answer will be returned, and this answer becomes the input to the print statement. So in this case, the return value is used by another function. And if you've taken, some algebra 2, you've actually seen this kind of thing where function composition, where I have f of g of x, and I start on the inside and work out. I call the g function using the input x. Whatever the result of that is, I then apply it as the input into the f function. That's the same way we have with line 4. We call the sphere volume function first with an input of 5. We figure out what it is. We receive the return value back, and that returned value then gets used as an input into this other function, the print function. Now, last line. Let's look at this last line just to see what happens here. Now, we call the function one more time with an input of 6, so we calculate the volume of a sphere with radius 6, and this value does get returned, but notice it just doesn't go anywhere at all. It does not get assigned to a variable, it does not get put into a function, and so in some sense it's a little bit wasted. It's a useless function call. The return value is unused. So all we did here was we did some calculation and we returned a value, but nothing really happened. So understand that unless we do some sort of assignment of the answer to a variable or feed it into another function, the return value is just going to be kind of wasted. Okay, so let's see how we can take the code that we started this lesson on and turn it into some other code using some functions. So we realize that there's a lot of repeated code, and instead, but not just repeated code, there's also some code that is different for each one of those two. So the blue is the different piece, the yellow is the same. So we're going to take the yellow piece and we're going to just kind of copy it inside my function. And the part of it that's different, actually I should highlight the print as well, the part that is different is then going to be fed into the function as parameters so that I could then, plug in Mark and hamburger in here, or maybe Mary and hot dog, or maybe John and pizza can be plugged in here. So you notice down here, I can call it introduce. So this 2 lines of code becomes this single line of code here, which is nice and readable. These two lines of code become this line of code here. These two lines of code become this line of code right here. Now, let's do the same thing with the sphere volume. We notice that, in this case, some repetitive code right there, and right there. But then we also notice some portions of it that are different. The different parts are going to be our parameter. And so we're going to create a function where we do this calculation. And the repeated, or the kind of the piece that is unique, will become my parameter r. So here I could turn this line in green into this line over here, sphere volume 7. This line here, 4/3 5r cubed, or 5 cubed, becomes sphere volume 5. And this line right here becomes sphere volume 11. And this is actually nice and readable. You know, it says, oh, this is the sphere volume of, radius 7, etc., etc. And the nice thing is, if I won't accidentally have an issue of having maybe some typos in this. Maybe I forget to put an extra asterisk here and it becomes multiplication. That would be bad. If I just have the equation in one place, then it's quite easy, if I did have an error, to fix it in one place and it would be fixed everywhere. Or if I wanted to change what the introduce me function does, and I wanted to say, oh, I love this favorite food, instead of I like the favorite food, I could change it in one place and all of a sudden they all now function in a different way. Okay, so now I want to have you try this problem on your own. Why don't you pause the video for a second? On the count of 3, I'll show you the answer. 3, 2, 1. So let's look at this. So first sentence says, define a fruitful function named square which receives a side length. So that's this length, the first line right here. Define square. And I chose the word length as the variable name. Then I'm going to print out this statement. The length is, comma, length, and the perimeter is, comma, length times 4 to calculate the perimeter. Then I'm going to return, that's the second thing I'm required to do in the definition of the problem, return the area of the square. So down here, return length squared. Now I need to call it, because the function doesn't do anything yet unless we call it. So I'm going to call the function with a side length of 12, and it says to assign the return value to the variable area, so I will do that. Area is equal to square of 10. Okay, that's the lesson for today. Have a good day, everybody.